Hello everyone, welcome to part 2 of this series, Assembly Tutorial for Beginners, where I teach you guys how to code in Assembly. And in the first episode, we installed the software that we're going to be using, which is called Code Warrior. And as you can see here, now we're in the folder of Code Warrior. And if we click on bin here, we can see that we have an IDE, which stands for Integrated Development Environment. And this is basically what we want to click on every time we run the program. So now that we clicked on it, we can create a new project, load an example, or choose any of these options. And I'm going to click on Create New Project. Now it's going to tell me to pick which family or which derivative I want to use. And I'm going to be using the one similarly used in college, which is going to be the MC9S12E128. And I'm going to use this full ship simulation. I'm not going to pick C, I'm actually going to pick the assembly because this is what this tutorial is about. And I'm going to name it here tutorial 1 with an underscore. So this is going to be the name, and then I can just click finish here. Now, as you can see, this is the main page, or basically this is the main thing that you need to get familiar with. And this is where you're going to code all of your assembly code in here. And as you can see here, we have sources, includes, and product setting. And as a beginner, we're only going to be focusing on sources. And we have one already made sources file, which is main.asm, and ASM stands for assembly. So we double click on it. And we can see here that there's basically something like a program that is already written for us. Now I'm basically going to delete most of it. All of these are just comments. Everything in red are just comments. So I'm going to delete all of these comments. You can look at it and understand what they're saying, but you don't need to have it. And I do think that they're a little bit distracting. And I'm going to explain everything in this program, or everything that is already written here, so that we understand it. So the first thing is include derivative.inc. And this is basically important to, just like in C or C++ where you include the library, this is going to be serving as that thing. Include derivative will allow us to use some of the keywords that are already defined. And after that, we see xdef and xref. Def means define, ref means reference. And xdef and xref you're going to be using all the time, especially when your code gets a little bit more complicated. Xdef, everything that is written here and separated by a comma. So we only have 3 terms here. We have entry, comma, underscore startup, comma, main. And entry, startup, and main, you can see them right here. So everything that we're going to be using in main, for example, these 3 keywords are going to be written in our define section. Now in the reference section, this is the stack pointer, and we're going to be talking a lot more about the stack pointer later. But basically, these 2 fields are extremely important when you work with subroutines, aka functions, or different files. We're going to be using these 2 sections. Now right here, we have my extended RAM section. In other words, variables section. The variable section is where you define all of your variables. So you know how in C or C++ or Java, you have a section, or not section, but you have to initialize whatever variable you're going to use. Let's say int var equals 0. This is the same thing what we're doing here. This is initializing the variable section. We can also have another section that they didn't add here, which is constant, and then colon, and then section. We can have them all capital or all small, it doesn't matter, but we have to make sure that we have this semicolon here. And now everything in this constant section is going to be our constants, and it's going to be how we define constants. Let's say we have con1 dc.b 0. So this constant right now is of value 0, and because it's a constant, it's never going to be changed. Variables, you can change their value, but the constants, from the name constant, it's not going to be changed. After that, we have the code section. And in the code section is basically where your code goes. And let's delete everything in here and write a very, very simple program. So as I told you, we have the main, startup, and entry, and all of these were already defined in this define section. So this is the layout, and now we're gonna start writing a simple program in assembly. Let's say we want to add two numbers together. We have a variable called counter and a variable called, let's actually change this name. Let's call it var2 and var1 just for simplicity. And we're gonna define them as byte. And I'm gonna tell you guys what ds.b mean versus ds.w versus dc.b versus dc.w. But for now, let's keep it simple. We have two variables, var1 and var2. So we're going to move a byte, which is 1, to var1. What this is, basically, we can write a comment by writing a semicolon here, and everything after that is going to be the comment, and it's going to be neglected by the program. Move byte 1 to var1 basically it's the same thing as saying var1 equals 1. So it's the same exact thing. We're moving a byte 1, so number 1 is a byte here, to the variable which is of size byte. As you can see here, ds.b, so it's defining a variable that is 1 byte. This 1 here define how many bytes, and b means byte. So var1 is 1 byte, and we're moving 1 to that byte, to that variable. And I forgot to have the columns here. And if I didn't include that, I will get an error when trying to compile. Now we have number 1 in var1. Okay, that sounds good. Now how do we add another number? Let's say we want to move 2 to var2. So now var1 is 1 and var2 is 2. Now how do I add them together? There's not a single instruction. You can't do, for example, var1 plus var2. This will give you an error. This doesn't make sense in assembly, at least in this assembly. So what you want to do is you want to use the accumulators or the memory to be able to add two numbers. And I'm going to go into more details about that later. But for now, follow along with me. We're going to load LD, as in load, accumulator A with var1. So basically, we have an accumulator that is already defined in assembly, which is called A. We have other accumulators, I'm going to be talking about them later. But for now, we have an accumulator A. And as you can see also, the instruction here is in blue. That means the instruction is already defined and the program knows what that is. So LDAA var1. Basically, this is saying let A be equals to var1. And var1 is 1, so A is equal to 1. Now what we're going to do here is we're going to add to A, ADDA, var2. So now we're adding to A, so A plus equals var2, which we know that var2 is equal to 2. A already had 1 plus 2 equals 3, so now A equals 3. So now that's how we add two numbers together, very, very simply. We first had to identify two constants, and then we moved a byte to variables, and then we moved bytes to these variables. We moved 1 and 2 to var1 and var2 respectively. Then to add them together, we learned how to deal with an accumulator called A. So we did LDAA var1, which equals to A equals var1, or move the value in var1 to A. Similar, it's all the same thing, synonyms. And then we added to that, because that's something you can do in assembly, you can add accumulators. So you can add something to an accumulator. We added the value, or the value that is stored in the variable 2, var2, to accumulator A, so 1 plus 2 equals A. And this concludes the first program. And in the next episode, I'm going to actually show you how to compile this, how to run it, and how to check if your answer is correct and your logic is correct. Thank you for watching, and I'll see you guys very soon.